We're going to try to use WinSteps today, so I don't know how successful you guys will be in terms of watching the slideshow on your computer and using WinSteps on your computer at the same time, but we'll see. I'm sure everything will work out. So we're going to start with a brief review of psychometrics, and as we've done before and as we'll do again. So you'll be seeing this material in a slightly different way each time. So that you have a chance, so basically so it has a chance to kind of really sink in. So we'll be looking at it from several different perspectives. Some of the slides will be repeated just because that's the nature of things. So when we talk about psychometrics, the idea behind psychometrics is that we can't make one big decision. I can't just ask you, are you neurotic? Are you extroverted? Are you conscientious? So instead of just asking you one big question about yourself and recording a single answer, because that answer is going to be very unreliable and probably not have much validity, I instead break the big question down into a series of small questions. Okay, and those small questions basically become the items. So the idea here is that many small decisions are definitely more reliable and more valid than one big decision. And if we have many small decisions to make, well, the small decisions essentially become our items, and our items are basically the signal from that accumulates where our items overlap. Every item contains signal as well as error variance, so presumably the signal is accumulating here in the center, and then the error variance is supposed to be randomly distributed around that. Okay, so we can contrast psychometrics. Psychometrics is kind of the measurement paradigm of psychology. We can contrast that with psychiatry. Psychiatry uses a different measurement paradigm, or it has historically. Instead of using psychometrics, it uses the medical model. So if you look at the DSM, for example, you have diagnostic criteria. The problem with the DSM has been that the level of inference really isn't standardized across the diagnostic criteria. So instead of, whereas psychometrics involves a series of small decisions, you make a series of small decisions about the subject. In the medical model, in the DSM, sometimes the diagnostic criteria are highly inferential. So if you have any diagnostic criteria that refer to personality structure, for example, or to anything resembling ego strength, those are just massively inferential diagnostic criteria. In other words, you're still faced with a big decision. It disobeys the fundamental principle of psychometrics, where you break big questions down into little questions, and that has tended to plague reliability in psychiatry, particularly reliability in the personality disorders. So not only are you taking something that is a continuum, like a personality trait that is supposed to vary from normality to pathology, not only are you breaking that continuum, splitting that continuum somewhere, which also contributes to the lack of reliability, but then you have these big decisions that are still left to be big decisions. So that's been a problem in psychiatry with the medical model, and DSM-5 is actually trying to get away from that. So DSM-5 is supposed to have continuity between normality and pathology, and that will improve the measurement characteristics of DSM-5 dramatically over DSM-4. So what we try to do in breaking the big decisions down into small decisions, we talk about content validity. As we've said, psychological constructs are not objects that exist in the real world. They're not physical objects like chemistry and physics. So instead of our constructs having boundaries, they don't have boundaries, they have soft boundaries. So again, if you're looking at the DSM, you have something called the prototypal model. In the prototypal model, some diagnostic criteria are believed to be more central to the construct than others. So what we try to do when we break the big questions down into small questions, we ask, what's in there? What's inside our construct? And then we struggle to focus, we struggle to find the stuff. First of all, we struggle to find what we believe are the essential parts of the construct, and then we struggle to find items that can assess those parts, and we try to focus those items on the construct. And if we're going to have an inventory, the class is supposed to be about inventory construction. So if we're going to have an inventory, we have to ask, where do our constructs come from? They can either come from two broad ways. They can either come from induction or deduction. In the inductive model, we go to the world and see what the world has in it. We try to make comprehensive observations, and we try to make them very detailed. And the idea is that if we observe long enough and hard enough and with enough scope, then the truth finally has to emerge. So we have something like the lexical model, for example. You go through the dictionary and you sample all the personality trait terms that are in the dictionary according to some definition of personality. And then all of this gets fed into a factor analysis, and out come the 5 factors or 6 factors or 7 factors. In a deductive model, and you notice I've got a cube here, right? In the deductive model, the theory gives us our constructs, and it's various combinations of the constructs. It's actually various combinations of the dimensions that then go to make up our constructs. So in a deductive model, we actually have a personality space. But regardless of where we get the constructs from, the measurement characteristics are similar, and that is that the construct occurs in the middle of the items, and then the error variance is out here, and it's the overlap of the items that's considered to be signal. Okay? So this is the kind of the classical model of psychometrics. The problem with this model is that it doesn't actually put the items on a scale, and that it's all about overlap. So we've talked about the 3-stage model. We've got the theoretical stage, the internal structural stage, and the external criterion stage. And this is kind of like a sieve. And good items are supposed to pass through all of the stages of the sieve. So good items are going to make sense theoretically. Good items are going to have adequate internal structural characteristics. So they're going to have high alphas, for example, high internal consistency. And then when the scale is finally composed, the scale is going to have relationships with other scales that are expected and predictable, and that's called construct validity. So if you go all the way back to the 1950s, when this paradigm of classical psychometrics was first being put forward, the guys who wrote about this, the seminal article is about construct validity, and it's written by a couple of guys named Cronbach and Meehl. And they simply talk about construct validity in an external way. In other words, it's each scale's relationship to other scales that's really important. Is the scale correlated highly with other scales that we would expect it to be correlated with? Does it not correlate with other scales that it should not correlate with? And so on. So this is a purely extrinsic definition of construct validity. The internal characteristics of the scale, the internal characteristics of validity, are mainly limited to alpha and maybe some of the correlations between the scales that we can inspect within an inventory. Okay? So the problem with this, and the reason that we've kind of left it behind, we focused on factor analysis at the beginning of the class. You guys had a lot of experience with that. Factor analysis is supposed to give us the parts of each construct. But the problem with this focus is that it lacks a rigorous definition of dimensionality. So alpha, internal consistency, yes, it is a measure of redundancy. It does put a number on the extent to which items are thematically similar, but overlap is not dimensionality. Historically, it's been treated as dimensionality, but overlap is not necessarily dimensionality. And that's led to a weird situation because the scales that are in use today typically have a long history behind them. But all of these scales, in fact, are designed with classical psychometrics, or most of them are still designed with classical psychometrics. And as a result of that, the scores on the scales are still sample dependent. And it's very dependent upon the normative sample from which the inventory was derived. And that means that unlike a Celsius-Fahrenheit situation, for example, if I want to know, if I have the temperature in Fahrenheit and I want to get that temperature in Celsius, all I have to do to change frames of reference is apply a mathematical formula. That's pretty easy to do. I can translate Fahrenheit to Celsius with no loss of precision. Okay, both frameworks are interval level and they're absolute. But if I want to know what the score on an MMPI-2 depression scale, if I want to know what that score means on a Beck depression inventory, then I have a problem because I don't really know what it means, right? I can do a study and I can construct a regression equation, but even that regression equation is going to have a certain amount of error involved in it. I don't know. I don't have a grasp of what the frame of measurement for each scale means until I use the scale sums. until I have a lot of experience using the scale. So if you have a lot of experience using the BDI, well, those scores are going to be meaningful to you. If you have a lot of experience using the MMPI, the score on the MMPI-2 depression scale will be meaningful to you. The same with the geriatric depression. But the scores can only be made meaningful by virtue of your experience with the scale and through the anchoring of the scale in the normative sample. Okay, and that's a little weird because, you know, you can imagine, as I said last time, you wake up in the morning and you ask your significant other, what is the temperature outside, and you get the question, well, it's a standard deviation above the norm. What does that mean, right? We don't think of temperature as being anchored on some kind of normative scale. We're used to just giving a number for that. And that's kind of how it ought to be in psychology. But it's not that way. And as a result of this, you see entire literatures that develop around certain scales. So if you have researchers who are interested in studying the relationship between, say, depression and introversion, for example, they might decide to operationalize depression with the Beck Depression Inventory, and then all subsequent researchers would do the same because they want to make sure that their studies are compatible with previous studies. That doesn't really make sense. That's like saying that I have to, anytime I go out and buy a ruler, I have to buy it at National Bookstore because if I buy it somewhere else, my ruler might be different than the one I had. We don't want that situation. We want all rulers to be the same, or at least if there are different frames of measurement created, we want to be able to translate one ruler to another the way we can translate Fahrenheit into Celsius, for example. So as a result, we're kind of stuck with this situation in which even our best measurement instruments are rather primitive, and they've been around forever. Think about the MMPI and the Rorschach, which have been around. The MMPI goes all the way back to the 1940s. The Milan inventories are a little better, the NEO's a little better, but what are really great instruments? It's tough to think of a really, really great instrument. So the question is, how are we going to revise this, and how are we going to raise the level of measurement in the field? And the way to do this is to consider something that we call the arrow of the construct, or the arrow of the variable. And this means that we have to have a much stronger theory of the construct than we typically do. Because in classical psychometrics, we're just asking the question, what does the construct have in it? We want to know the parts, and then we can decompose the parts into items. So when we have enough detail about the construct in classical psychometrics, we can start inventing items. In this measurement paradigm, we want to have a theory that's strong enough so that it not only gives us the parts, but it arranges the parts in a particular order for us. And the order in which the parts are arranged, as dictated by the theory, is called the item hierarchy. So if you look at arithmetic, for example, the first thing you learn, your mom starts counting on your fingers, and when you're a little kid, and you learn addition. And after you learn addition, it's easy to count in reverse on your fingers, and you learn subtraction. Multiplication is logical because it's just a successive series of additions, and then division is the hardest thing to learn. So these skills tend to emerge, these arithmetic skills tend to emerge in a particular order, and they emerge in an order that suggests less ability, addition being the easiest, to more ability, division. As long as somebody gives you a pencil and enough time, and maybe a calculator, you can pretty much divide any number by any other number, and you can check your results. In classical psychometrics, we don't have that. We just have alpha, and we have the idea of covariance. But you see this idea of more, this idea of stages where phenomena emerge in an orderly fashion. You see this idea again and again in psychology. So, for example, with Piaget, you see the sensory motor period, the pre-operational period, the concrete operational period, formal operational period. Those periods of cognitive development, they emerge in that order. And that order doesn't vary. That order is invariant. You see it in Freud. The place where you see it in personality testing is probably comes closest is probably Freud. So you've got the oral stage, and then following that you've got the anal stage, and then the phallic stage, and then the genital stage. But unfortunately, Freud's work has had enormous influence, but when you think of measurement, you think of psychoanalysis as probably being the opposite of measurement, right? Because the constructs are so inferential. But you do see this idea of more and stages over and over and over again. We don't see it as much in personality, and the reason that we don't is because in cognitive psychology, for example, everyone is believed to pass through an invariant sequence of stages, whereas in personality has been historically focused on taxonomy. The question is, how do people distribute themselves into these stages? So each one of these, and you can talk about this is true no matter what taxonomy of personality you're talking about. So for example, if you're talking about the Jungian stuff, well, here we have a set of 16 categories. How do people distribute themselves into those 16 categories? That's the developmental question. Each one of these categories presumably has its own developmental pathway. Here's the interpersonal circle. Dominance and communion are the axes of the interpersonal circle. How do people distribute themselves in terms of this personality space? And again, the big five, the question, how do people acquire the profile that they do in which one of these particular factors is higher than the others in a five-dimensional space? So in personality, it's about people distributing themselves into a space. In the cognitive paradigm, it's about passing through stages. As a result of that, measurement in personality psychology has lagged the rest of the field, and we still tend to be focused mainly on alpha and accounting for variance and correlations, and we're obsessed with factor analysis. So we're obsessed in trying to determine whether there's 5 factors or whether there's 6 factors or 7 factors to personality. Those kinds of questions have dominated the field. If we try to construct measures in which theory is stronger, in which theory gives us the order of the items, this is something which is called criterion referencing. And criterion referencing is supposed to be a stronger idea than content validity. So content validity, when we talk about content validity in classical psychometrics, everything is on the same level. All of the items are more or less on the same level. We look at the items and we know that that's not true. Okay, just our common sense tells us that some items are more difficult than others. But the measurement paradigm we're working with, the items are more or less on the same level. In criterion referencing, you're basically asked to put the items into a particular order, and the theory is dictating the order. And because the theory is dictating the order, and because we have a stronger idea, we have a strong idea of dimensionality, because of that, it means that our idea about construct validity has changed. So remember, we talked about Cronbach and Meehl, and we said that construct validity was all about whether a scale had the appropriate set of relations with other scales. That's an external conception of validity. In the Roche model and in criterion referencing, we have much more of an internal conception of validity because we're trying to validate the difficulty level, the sequencing of our items. So validity has now ceased to be purely external, and it's now also much more internal. The two things are very balanced. So for example, say that you are trying to construct a test which measures religiosity as a personality dimension. Maybe you have ideas about the different items, different characteristics that might be measured among normal people, and this would be over here. But then you believe at high levels of religiosity, other phenomena observed, and those phenomena can only be reported by people who are actually involved in the institution of religion. So maybe you need to search out priests and nuns and other people who are especially spiritual in order to observe these religious phenomena. So this would be an example of criterion referencing. It's not just about dividing religiosity up into parts and thinking of items that correspond with those parts. It's also about sequencing the items into a particular order. You might, in fact, use a sample of ordinary persons in order to construct your preliminary ruler, okay? But then you would try to extend the ruler by going to people who are more involved in religion, more involved in the church, more involved in spirituality. So here is the ruler. Here's you have a picture of a ruler, and these would be ordinary people. And the Roche model will construct our ruler in such a way that all of the intervals along our ruler are equal. So the difference between 1 and 2 is equal to the difference between 2 and 3 is equal to the difference between 5 and 6, for example. In the Roche model, These units are called logits, and logit doesn't correspond to anything in the physical world, nor would you want it to, because we're dealing with psychological constructs, right? So we obtain a sample of normals. We let our theory dictate the order among the items. We do some validity work by giving our items to a set of normals in order to derive a preliminary ruler. And then maybe we go out and we find people that are especially spiritual, and we can extend our ruler, we can extend our framework of measurement by including those in the sample, and we can see if they also obey the item hierarchy. So that's the idea. The theory says that the items should emerge in a particular order. Now, having said that, there are really two ways that the Roche model tends to be used in personality. And the way that I've described to you is really a much stronger sense of the use of the Roche model, because it's all about theory and the order in which the theory puts the items. And we tried to get a little bit of that in, because when you guys generated the items, we talked about the maladaptive stuff. When you guys generated the items that were supposed to be maladaptive, you were kind of asked to think outside the box in that sense. So we had the question, we have virtues, and virtues are supposed to be good. They're supposed to be good for us all the time. You can't be too virtuous, right? But the question that we asked was, what happens to the person if you have too much hope? Or what happens if you're too courageous, for example? Or what happens if you're too spiritual, for example? So we were actually considering the arrow of the variable. If we look at this process in the context of a Roche paradigm, we were actually considering the variable at the upper ends, and we were trying to put the items into an explicit order in terms of the item hierarchy as dictated by the theory. You were developing a kind of theory of the construct that tells us what happens at the upper echelons of the construct. Okay? That is the strong sense in terms of using the Roche model, where there is this strong interplay between the theory and the items, and we're trying to validate the item hierarchy, just like we might try to validate Piaget's stages, for example. Okay, if you were trying to validate Piaget's stages, you wouldn't want to go out and find that people were in stage 3 one particular month, and then the next month they were back to stage 1. You wouldn't want that to happen. You would want everybody to be in stage 1, and then everybody's in stage 2, and then people go into stage 3, and then they go into stage 4. If people start slipping up and down the stages, well, then the item order probably doesn't have any validity associated with it. So we tried to do that. That's the strong sense of using the Roche model, and we got a little bit of that when we tried to talk about the maladaptive items. You guys were beginning to develop a theory in which the item hierarchy for those constructs, those virtues, would be important. That's the strong sense. The weak sense of it is that we go ahead and we use content validity questions. We ask ourselves what the parts of the construct are. We derive a lot of items, and then we let the Roche model arrange those items in terms of their difficulty, and we kind of see if we can get a theory out of that later on. Okay, so it's as if we want all the measurement goodness of the Roche model, but we don't really, in terms of the weak application of it, we want all the goodness of the Roche model because we want to be able to consider different difficulty levels of our items. We want all the precision of the Roche model, but we don't really have a strong theory, and we're just kind of waiting to see what comes out of that, what comes out of our analysis. So our theory kind of develops after the fact. And that's still how things tend to be done in personality psychology when it's applied to the Roche model. So let's actually take a look at the Roche model and see if we can decide what the essence of it is. And George Roche was a Danish philosopher and mathematician and statistician, and he did a lot of freelance work, a lot of freelance statistical work, and one of the things that he was known for, he didn't like to apply models that already existed. He was a bit of a maverick in this way. Roche was somebody who would go out and try to think up novel approaches to a problem that nobody had ever thought of before. And he was trying to do this. He was faced with some intelligence data. He had been retained by the government in order to try to make sense of some intelligence data. And this is where the Roche model comes from. This is one of the cases where he tried to develop a completely novel approach. And so Roche asked the question, what happens when a person meets an item? And Roche realized that the relationship between person and item, it's not a deterministic relationship in which you pass some items and then you fail all subsequent items as it is in a Gutman scale. The relationship between person and item is probabilistic. So at first, if the items are too hard, you will fail the items. So let's say you have a mathematics item that you're faced with, and that mathematics item is this item, 108 times 34 to the 12th power over pi. You're not going to be able to pass that item unless you have a calculator, right? So if that item is too hard, you're going to fail that item. But there are items that are approximately within your zone of ability. Okay, so if you have an item like, say, 34 times 27, and you're asked to carry that calculation out in your head, you may be able to do it. You may be able to be successful in that item. So there's a whole family of items around there in terms of these two-digit multiplication problems that you might be able to do successfully in your head. The difficulty of those items is going to be approximately equal to your ability. So it becomes kind of like a tug of war or a chess match. And you're not really able to guess in advance, since the item difficulty is approximately equal to person ability. You're not really able to guess in advance which one is going to prevail, person and item. And the point at which item difficulty and person ability are the same, where you have a 50% chance of passing the item, well, that's right here. That falls right here on the scale, and this is the point that we're supposed to learn the most about you. If we go over here to this end where all the problems are too hard and you fail all the problems, we learn nothing about you. So if we want to know something about your chess playing ability, and let's say you face Garry Kasparov, who is the former world chess champion, in a match, and it's a 20-game match, well, you lose all the games, we learn nothing about your chess playing ability. We only learn something about you when you actually begin to pass or fail the items. If you fail all the items, we learn nothing about you. If you pass all the items, again, we learn nothing about you. But as soon as you begin to pass or fail items, and there's a mix of that passing and failing, then you can be located on this logistic curve. Then we have information about you. And the point at which we get the most information about you is where the items are approximately matched. The difficulty of the items is approximately matched to your ability. Okay? So if we take that idea and we extrapolate it to a group of people, and if we arrange the items in such a way that the easiest items are over here on the left and the hard items are on the right, and the persons of high ability are up here and the persons of low ability are down here, if we arrange things like this, then we have this nice little scalegram arrangement that you saw last time, and we have three zones in the data. So in this zone over here on the left, all items are passed. So the first item here, the easiest items are on the left. The first item is 2 plus 2. Everyone in the sample passes that item. Second item is 2 plus 3. Everyone in the sample passes that item. The next item is, say, 12 plus 17. Most of the people in the sample pass that item. The items are getting harder, though. They're arranged from easiest to most difficult, but they're getting harder. So over here you have an item like 37 plus 122, and you can see that there are people here who are beginning to fail this item. So this is what we call the transition zone. As the items get harder, eventually the difficulty level of the items begins to match the ability of each person in the sample. So up here, the most difficult items are hopefully matched to the most able people in the sample, and we're going to see a series of ones and zeros. We're going to see failures here. If we have this person of tremendous ability and they succeed on all of our items, we learn nothing about them. So our goal is to construct an instrument in which the item difficulties are matched to the abilities of pretty much everybody who's in our sample. That way we have a chance to learn about everybody in our sample. So over here, these are items that we can expect failures to occur, and these are very difficult items, or at least very difficult items for the subject. So this item here in the column, this item here in the rightmost column might be something like 127 plus 1342, something like that. That's going to be a difficult item for a lot of people, right? So that item is going to be failed a lot. And that item is ridiculously too hard for our lowest ability subjects, but it's probably matching the ability, its difficulty matches the ability of our highest, most capable subjects. So again, three zones in the data: a zone where we expect all items to be passed, a zone where we expect all items to be failed, and then a transition zone here in the middle. And in this transition zone, this is a region of chaos. Over here we expect order. We expect there to be all ones. Over here we expect there to be all zeros. And then in this transition zone, well, in the transition zone, our expectations about the sequence of ones and zeros is weaker because person ability and item difficulty are approximately equal. So the most that we can say about the pattern that we expect in the transition zone is, well, over here on the left of the transition zone, we kind of expect to be able to see more passes than failures. And over here on the right of the transition zone, we kind of expect to be able to see more failures than passes. So more passes than failures over here, more failures than passes over here, but still it's a zone of chaos, and we don't have really strong expectations about the pattern that should emerge here. Okay? The key question that the Rasch model is faced with, and that we're faced with, is how do we use this matrix? How do we get interval level data out of this matrix? Because this is just ones and zeros. That's all it is. It's just qualitative observations. There's nothing else involved here. How do you get something as profound as a ruler? You know, we're in the social sciences, we're used to measurement being very soft. In the physical sciences, we're used to having rulers that give us precise measures. How can we get precise measures out of a matrix that consists just of ones and just of zeros? And that's the key question. We want to go from qualitative data to quantitative data. Even if we're working with Likert type items that vary from, say, strongly disagree to strongly agree, that's still qualitative data. So we want to go from qualitative data to quantitative data. And the key insight here, getting the solution to this problem, is to recognize that that everything here is based upon proportions. So if we add a row and a column to our table, well, we've got the proportions over here. The proportions of passing and failing are over here in the right-hand column and also down here in this bottom row. So, for example, for this person, person A, we've got 1, 2, 3, 4, 5, 6, 7, 8 passes and 1 failure. And so that proportion is equal to 0.89. Here we have, it looks like, here it looks like we have 8 passes and 2 failures, and this is 0.80. Okay? So we can calculate the proportion of passes and failures for every person in the sample, and we can also calculate that proportion for every item in the sample. So now that we were able to calculate the proportions, how do we go from the proportions to interval level data? The problem that we have with the proportion is that it varies from 0 to 1. So this is like 0 to 100%. So you remember when you were a kid and you brought home the scores on your mathematics test and you brought home a 99 or 100, that was supposed to be really good. And that was supposed to be measurement. That was measurement in the classroom that was conducted in the classroom. So that's 100% is supposed to be a really good number. But what happens if all of the kids in the classroom are getting 100%? Or all of the kids in the classroom are getting 90%? Or all the kids in the classroom are getting 95%? It must mean that either the kids are really smart or the items are really easy, right? So even though you're able to put measurement in a framework that varies from 0 to 100%, it doesn't necessarily mean that the measurements that you're making are good, because we don't really have an idea of how smart the kids are, and we don't really have an idea of how difficult the items are. And besides that, the problem with proportion is, well, it's finite. It only varies from 0 to 1. If you look at what happens in chemistry and physics, well, you can have an infinite amount of length and you can have an infinite amount of mass. So it would be desirable if our measures, in order to be genuinely continuous, it would be desirable if our measures were able to continue infinitely in one direction or another. In order to transform this proportion into an interval level measurement, we take the natural log odds, the natural log of 1 minus the probability of success, which is really the probability of failure. So it's the natural log of the probability of failure divided by the probability of success. And this then converts a proportion that varies from 0 to 1 to a scale that essentially varies from 0 to infinity. Okay? So we plug in some numbers just to see how this works. If we have 70% passing and 30% failing, then we take the log of 30.30 over 0.70, and that comes out to be minus 0.85. If we have a situation in which 5% are passing and 95% are failing, we take the log of 0.95 divided by 0.05, and that turns out to be 2.94. So as you can see here, this 2.94 is greater than 1. Problem with the proportion is that it only goes up to 1. Well, we've escaped the boundaries of 0 and 1 here. And in fact, we've created a scale in which the numbers essentially go on to infinity. And if we have a situation in which only 0.1% of our sample is passing an item, well, that must be an incredibly difficult item, right? Because 99.9% are failing. If we take the log of that, 0.999 over 0.001, we come up with a number 6.91. So as you can see, this item is incredibly difficult. So difficult items are going to have a positive value. The result of that, of taking this mathematical equation, constructing the result of this, difficult items are going to have a high positive value, and easy items are going to have a negative value, or at least items that, I'm saying difficult and easier as if it were a quality that existed in the universe out there. This is easier or difficult relative to the ability of our sample. Okay? So if we have a situation in which the difficulty of an item is equal to the ability of the sample, so that 50% of the subjects pass the item and 50% of the subjects fail the item, then we're going to have a 0 here. Okay? So we do this, come back to our data matrix here. Here's our data. It's just ones and zeros. And then we added a column here and a row down here in order to construct the proportions. And then we do the transformation, the natural log odds transformation, and we come up with a column which we call the ability logit, and we come up with a row that we call the difficulty logit. And this becomes our first approximation. This becomes our first approximation to the person abilities and the item difficulties. And then what WinSteps does, it uses these first approximations. It tries to reconstruct the original matrix, and it continues to fine-tune the numbers until it can minimize the number of errors that are made in terms of constructing this matrix. So one of the things to notice about this is that missing data doesn't really hurt us. Typically in the social sciences, if we have missing data, well, if we have too much missing data, it's a nightmare, right? It can potentially invalidate our measurements. In the Roche model, missing data doesn't necessarily hurt us as long as it's missing at random. The reason it doesn't hurt us is because we can still construct a proportion out of the remaining items. And that's a very good thing. Missing data isn't going to be our enemy. Now, one of the things that you can come up with in WinSteps, since we have this nice little grid here in which we have the abilities of every person and the difficulties of every item, this puts the items and the persons in the same frame of reference, in the same frame of measurement. And it means that we can plot these on a chart. And this is called the person-item map over here. So the ability logits would actually be down here. I've got the arrows wrong on the chart. And the item difficulties would actually be over here. So this is the item difficulties, and this is the person abilities. This takes this nice little grid of ones and zeros. You start with a nice little grid of ones and zeros, calculate your proportions, estimate your ability and difficulties in logits, and then that becomes the person item map. Okay? And if we look at this, we immediately get an idea of what's called targeting. And targeting has to do with the extent to which the item difficulties and person abilities are closely matched. So if we look at this particular graph, we can see that these items were intended to assess recklessness, which is a pathological trait. So in this particular situation, the item difficulties are higher than the person's have-ability. Most of our persons are down here, and most of our item difficulties are up here. If you look at these little, you'll notice there are some little letters here. There's an M right here, and that is the mean of the item difficulties. There's an M over here, and this is the mean of the person abilities. So if you want to get a quick idea of how good targeting is, basically look at the distance between the item difficulties and the person abilities, the means of those two, and that gives you a quick idea of how good the targeting is. Or you can just basically eyeball the whole distribution. Okay. So if you wanted maximum precision of measurement, you would want a situation in which the mean of the item difficulties and the mean of the person abilities were the same. That would give you maximum precision of measurement across the entire range of the sample. You may, however, want a situation in which you have the most measurement up here where clinical decisions are made. So, for example, if you're giving the NEO, well, high score on the NEO is going to be something like T-score of 60 or T-score of 65, as on the MMPI. There's going to be a cutting zone there somewhere where the subject enters a clinical range. That's where you decide whether they go down a clinical pathway or not. If the person scores a T-score of 49 and a T-score of 50 is average, well, the fact that they got the 49, okay, well, that's great that you know it's a 49, but it doesn't mean anything. It has no implications for the subject clinically. We don't need a whole lot of measurement precision around a T-score of 50, even though that's average, because nothing happens to the person in that situation. If you're working with clinical scales where you have a cutoff point around a certain T-score, you want the most measurement precision to be up here. This means that you want the item difficulties to center on where clinical decisions are made. So you want the most measurement precision around, say, T-score 60 or 65. You're hoping that the items are not exactly targeted to the sample in that situation. All right? Another thing to notice about this, if we're working with Likert type data, is that we can naturally expect the levels of the items to vary with the levels of the trait. So if the item is I'll take chances if it makes things more interesting, well, if that item actually strongly measures the trait of recklessness, we expect to see these different levels of the item to be widely spaced and regularly spaced. They need to occur in a particular order. Okay? And remember, we talked about the item hierarchy. We said that the theory dictates the order in which the items fall. You've got a similar situation here because naturally we expect strongly disagree. If you strongly disagree to I'll take chances if it makes things more exciting, if you strongly disagree with that, then you have less of the trait. If you strongly agree with that, then you probably have more of the trait. So again, we see this idea that we need to have an ordering, and we see this even within the levels of an item. Okay? If the item is not a good item, then we would expect to see something like this, where we have strongly disagree, strongly agree, strongly disagree, strongly agree, disagree. Well, wait a minute. How is it that the people who strongly agree to this item have less of the trait than the people who disagree? That doesn't make sense anymore. In other words, the levels of the item are disordered. If we don't see this nice arrangement in terms of what the levels of the item may not be a good item. So we can say that the item is disordered or the item is narrow. All right? If we actually look at a real situation, this was taken from submissiveness, and these are the items that were on this submissiveness scale. Here is a situation in which this item is narrow, will agree to anything. So yes, it sounds like this would be a good item. Somebody who is submissive will agree to everything. But when you actually do the statistics, it turns out that the levels of the Likert type item are close together. So this item is probably not very highly correlated with the scale, probably not a great item. The item can probably be deleted. And then once the item is deleted, the rest of the scale will go ahead and improve. Okay? We can also talk about something called infit and outfit. And infit and outfit are basically concerned with this matrix. We go back to this matrix. And we said that the relationship between personability and item difficulty was probabilistic. So that means that even though we have this zone here, this transition zone in which personability and item difficulty are approximately equal, and we expect chaos in this transition zone, there's still a possibility that somebody may pass, somebody may fail an easy item, and there's still the possibility that someone may pass a very difficult item. So these items over here tend to violate. If you see a 0 in the ones, and if you see a 1 in the zeros, that means that the score on these items is violating our expectation. And to the extent that our expectations are violated, that contributes to a statistic which is called outfit. So here's, if we look at a single logistic curve, infit is going to concern itself with the situation where personability and item difficulty are approximately equal. And then over here we have situations in which the person should have failed the item but passed. And over here we have a situation in which the person should have passed the item but failed. These situations are going to contribute to outfit, statistic called outfit. Okay, so go ahead and start WinSteps. And I'm going to wait for you guys to go ahead and start WinSteps. And you should have gotten the email that I sent out that had the PowerPoint as well as the data file and a WinSteps file inside it. Now, the first time that you start WinSteps, you're going to see this screen, and this is called the WinSteps welcome screen. Are you guys seeing that? Okay. The first thing that you want to do when you see the WinSteps welcome screen, you'll notice that there's a little box here that says "Don't ask again." Just go ahead and click that box and turn that off. So you can go ahead and click that box and then click no. You don't want any help setting up your analysis. And once you do that, you will never see that box again. And for me, that's a desirable thing. And then we want to make things a little bit easier. Go to the Edit menu on WinSteps, and I think at the bottom of the Edit menu, there's a menu item called Edit Initial Settings. Select that menu item, and you'll pop up this box. And on the left, about 3/4 of the way down, you'll see these two things: prompt for report output file name. Every time WinSteps runs, it asks you for a file name where you want to save your output, because WinSteps generates a tremendous amount of output. So it will ask you the file name that you want to save your output under. That can get rather annoying if you're just going through scales. So you want to make sure that this is unchecked. And then WinSteps will also ask you for something called extra specification. So if you want to introduce constraints on a particular analysis, WinSteps has a lot of parameters associated with it. If you want to include in WinSteps certain parameters that will only be for the current analysis, the one that's about to run, you can do that. Uncheck this box and WinSteps will not ask you for these extra specifications anymore. That'll make things a little easier. And also you'll see there's an item here called Close Output Windows on Exit, because WinSteps dumps all of its output into a notepad window. And when I first realized that, I thought that was crazy, but now I actually kind of like it. But yes, you want to make sure that WinSteps closes all the output windows on exit. So what's going to happen is you're going to run WinSteps, and as soon as you tell WinSteps where the data file is, WinSteps will go ahead and run and will pull all of the output into a notepad window that will pop up on your screen. Okay. So having done that, let's talk about how to import data into WinSteps. And if you're running WinSteps now, you'll notice that there is a menu item that's called Excel/RSSST. You guys see that? Okay, so go ahead and click that. And when you click that, you're going to notice that this little box pops up. Are you guys with me? Okay, so you're going to notice that this little box pops up, and you're going to see the SPSS button here. You'll notice that WinSteps can actually import data from a variety of different things. It can import data from SPSS, SAS, R, Excel, and Stata. The only one that we're going to worry about is SPSS. So go ahead and click the SPSS button. Okay. I'm going to wait until I know that you guys are with me. Are we all together? Okay. So once you've clicked that SPSS button, then you'll see a window that looks like this. Go ahead and click Select SPSS File. All right. And the files that I sent to each of you guys by email earlier, you want to find the anxiousness SPSS file. I think it's called anxiousness.sav. You probably saved it on your desktop. So are we good? Okay. So you found the file, the anxiety file, and you selected that. And WinSteps is going to go through that file and try to determine what its internal structure is. So WinSteps has a way of reading these files that are saved in SPSS format and trying to determine how many variables and how many subjects are actually saved within each SPSS file. So you should see a window that looks something like this on your screen, and this is what the top of the window will look like. So the top of the window just has this explanatory text. Go ahead and read this explanatory text.
Variables 1. Bachelor minus 17, theirs is 18.
What's that, HA?
Number of variables. Number of variables. 18. Yours is 17.
Oh yeah, that's okay. It's all right. I probably sent you a file that was just a little bit different. But this is just for purposes of illustration anyway, so it doesn't matter if it's exactly the same. So But we're all together, right? That's the thing that really matters. Okay, so you guys are seeing this screen. You've read this explanatory text. And then if you scroll down, you're going to see the rest of this. Okay, so you're going to see a red line that says item response variables. And then you're going to see this warning, this ominous warning, do not delete this line. If you do delete this line, WinSteps will not know what your items are. And then you'll see this other line, person label variables, and another ominous warning, do not delete this line. And then below that, you're going to see a list of what WinSteps calls other variables, and then it says ignored. And at the beginning, it looks as if WinSteps has ignored all of the variables in your data file. And that's not a good thing, right? So what you have to do is you want to copy the items and you want to paste it underneath where it says item response variables. So the items here begin FFM001 and go all the way to the bottom with hex 176. So go ahead and copy everything that runs from FFM001 to hex 176. Copy all of that and paste it underneath here where it says item response variables. Okay, and once you've copied the items, you'll want to copy the person variables. You're going to have data on your persons as well in any data file. So go ahead and copy gender and the name. Copy gender and name and paste it underneath where it says person label variables. And the reason you have to do this is because WinSteps doesn't know which variables are item variables and which variables are person variables, so you have to tell it. Okay, so here is what here you can see I've copied the item variables. And here you can see I've copied the person variables.
Gender, name. Roger said copy and paste, right? Ask for copy or copy.
You can do either one because WinSteps will ignore everything that's underneath the other variables. So you can either copy or cut. Cut and paste is probably better.
Yes.
Okay, so did you guys make it this far? Success? Okay, good. Then you'll notice that there's a button called Construct WinSteps file up here. Okay, see this button? You'll either click that button or this button that says Control and Data File. You can decide whether you want WinSteps to put your control and data, your controls are like programming statements. You can either put all of that into one file, your data and your commands in one file, or you can put your data and commands in separate files. If you put it in the same file, it becomes more portable and nothing gets lost. So we'll just go ahead and click this button, Construct WinSteps File, and that means that our commands and our data will be in a single file. So go ahead and click this button. Okay. So we've all clicked the button now. And now a box is going to pop up and it asks us where we want to save our new WinSteps file. And WinSteps saves all of this stuff as text files. So the extension is .txt. So that's kind of nice because it means you can load it into any word processor and edit it. Or you can even load it into Notepad and edit it. So it's asking us here, where do we want to save the file? If you created a directory called Psychometrics or whatever directory you created when you unzipped the files that I sent to you, just call the file Anxiety and save this file back into that directory. And at least you know where the file is. Because the first time you run WinSteps, it's going to be asking you what file you want. So you have to find this file again. So save this to your desktop or back into the directory where you had the SPSS data file. Are we all together?
Yes.
Okay. So then go to the file in Notepad. You should be able just to go to the file and double click on it, and it should launch automatically in Notepad because Notepad knows to open .txt files when you click on them. So set WinSteps aside for the moment, navigate to the file, and double click on it, navigate to your anxiety.txt file, and Notepad should automatically launch, and you should see the file loaded up, and it should look something like this. Okay, so this is how your file will look. It'll look similar to this. Are we all together?
Yes.
Okay, good. All right, so the thing to notice about this file is that it contains 3 regions. So up here at the top, these are your commands. And then down here, these are your items. And then at the bottom, this is your actual data. So WinSteps was able to extract the names of the items, and if there were variable labels associated with the items, usually the item name will be something like item 001, and then there'll be a variable label which is associated with that, which is the actual text of the item, like I like to take chances. If you're trying to measure recklessness or something, that would be the variable label. So what it does is it puts the actual variable name, the actual item name right here, and then it puts the variable label right here, okay? And then it puts the entry number right here. So this is item 1, and then you're going to see 1-1. If there's no variable label, then I think it just puts item 1, item 2, item 3, and so on. Okay, so this is the variable name for each item. This is the variable label, if any, and then this is just 1, 2, 3, 4, 5. This is just the entry order. And then down here, as I said, is the actual data, which is extracted from SPSS for your items. These are the actual endorsements of the item levels. And then this would be something like there's 1s and 2s here. This would be something like gender, and this would be the person's name. Okay? So you've got room here in the data file for the actual data as well as any person variables that you might want. And then, as I said, up here are the commands. So let's go through this file line by line so that you know what every line means. So up here at the top, you'll see that you've got the title of the original SPSS file, anxiousness.sav or anxiety.sav. Following that, you have the number of cases that were processed. There were 648 cases, and then the variables, you've got 17 or 18 that were processed. So this kind of gives you the history of the file. We know where the file came from. If you ever open a WinSteps file and you're wondering where in life it originated, well, you just go to the very top of the file, and this will tell you right here. Okay? And then these next two lines, it says item 1 equals 1 and NI equals 16. Well, these items and the names down here at the bottom are laid out as a grid. So this is telling us what column the item responses start in. The item responses start immediately, so they start in column 1. This is column 1 down here. So this is column 1, this is column 2, this is column 3, this is column 4. The item responses start in column 1, and then they run 16 columns because there are 16 items. So that tells us something about the structure of the data file. Then it says name 1 equals 18. And that's basically the column in which the person labels start. They start in the 18th column, and the width of these is 16. So there's been 16 columns that are set aside for person data here. Okay? And you'll notice these lines contain semicolons in them. Everything, and this is actually very important, everything in WinSteps that's after a semicolon is a comment. So when WinSteps is reading through this command file, it sees item 1 equals 1, and that has meaning to it. It takes some action based on that. And then there's a semicolon. So everything else is just to make the command file human readable. Everything after the semicolon is a comment. All right? And that doesn't appear to be important now, but it will be important later. So then we've had this line x wide equals 1. That basically tells us how many columns wide a variable is. So down here, if we look at the data, all of our data are 1 column wide. So x wide is going to be equal to 1. You might have data in which the responses varied from 1 to 10. 10 is going to be 2 columns, obviously. And that means that x wide would be equal to 2. Okay? Then the next line is called groups equals 0, and it says partial credit model. We want to change this line. Change this line to groups equal, and then empty quotation marks with nothing inside them. And the reason that we do this is because there's an entire family of Roche models. We're studying one. We're going to focus on what's called the rating scale model. So in order to tell WinSteps which Roche model we want, we type groups equals quotation mark. Okay? And then if you want to, you can change this partial credit model. You can wipe out the partial credit, and you can just type in rating scale model. All right? Okay, and then we have another line.
Raj, this is Valerie. Question.
Yeah, go ahead, Val.
Inside the groups, there's a semicolon. Below xy equals 1, and then below that is groups. Before groups, there's semicolon and a space. Is there supposed to be a semicolon there?
Okay, so it's groups.
One on yours.
Yeah, so it's groups equals. It should be groups.
No, before the word groups, there's a semicolon and a space.
Raj, in your file, you have semicolon and groups.
Oh, yeah. You can just, yeah, I know what you're talking about now. You can just wipe out that semicolon. I think when WinSteps first runs, the group statement is commented out. You can just wipe out that first semicolon and put groups equals quotation marks. So that the word groups is actually read as a command. But yeah, you're right. There is a leading semicolon there. That's right.
And then there's no space between the two quotation marks?
That's right. There's no space inside those two quotation marks.
So Raj, are we going to delete the semicolon?
Yes, delete the semicolon.
Delete semicolon.
Thank you, Valerie.
Remember, if the line has a semicolon, our instance will be as a comment rather than a comment. So like this one,
Okay. Okay, and below that there's a line that says codes equals 1, 2, 3, 4, 5, period. So these are the different levels of the Likert variables that WinSteps found in the item. And you'll notice that there's that period there, and that's kind of funny. Why should that be there, right? Well, that was missing data in the SPSS file. So you want to go ahead and remove that trailing period. So go ahead and remove that trailing period. Otherwise, WinSteps thinks that's a level. That WinSteps will think that's a valid response. You want to list the valid responses here after the code statement. The only valid responses are 1, 2, 3, 4, and 5. Anything that's not listed there becomes missing data. So if WinSteps finds a 9 in the data, that data is missing. It doesn't know what to do with it. So it just says, oh, it must be missing data. It wasn't a valid code. The period was missing data in the original SPSS file. You guys are with me?
yes.
Okay. And then the next line says total score equals yes. If it says total score is equal to yes, then persons that have extreme responses will be reported in the output. What do we mean by extreme responses? These are people who failed every item. So technically, somebody who passes every item or fails every item, we can't get an ability estimate on them. The reason that we can't is because if you take the natural log of 0, well, it's undefined. Okay, somebody who fails every item, we can't get any information about them. But we can, in fact, report them in terms of frequency tables. So if you type total score is equal to yes, they will be reported in the output. They won't have ability levels assigned to them, and items which are extreme won't have difficulty levels assigned to them. But you'll see their presence in the output, and hopefully there are not too many of those. Okay, and then you'll see a semicolon, and it says person label variables, and the person label variables that we told WinSteps to extract from our SPSS file are here, and their names are gender, and then person name, and then this is the actual columns. These are actual location codes, so that WinSteps knows where they are in the data file. Okay. And then below that, you're going to see that we have a list of items, so that's not too profound. And then below that, you're going to see what the actual data is. We want to insert some stuff into our data file. All right? So up here, this area that's shaded light red, you see the group statement, you see the code statement, you see the total score statement. Locate that in your file. And then down here at the bottom, you'll see this in your file where it says person label variables. Go ahead and type in, below where it says total score is equal to yes, go ahead and type in all this stuff in white into your file. So that'll take you about 5 minutes. So while you guys are doing that, I'm going to take a break and get some coffee.
Okay.
Still typing?
hyphens, then you have number 1. Under number 1, you have the letter D. So it has to match. Okay. So that means you're saying that item number 1, ID for is equal to B.
So you have to add more items.
Yes. And that 1 should match the letter B. It's your guide flag. In number 1, it's saying that item number 1 has a scoring of
You don't know exactly what
So when you put it in your text, just make sure the number here will match the letter. Like this is number 1, ID for is B. That means B is reverse calling. So item 1 is the reverse calling. Match it.
You guys still typing?
space O.
Still typing?
Question.
Yeah.
The portion that says I value A equals 1, 2, 3, 4, 5 and I value B equals 5, 4, 3, 2, 1.
Yeah.
There's a large space between that and the semicolon. Is there a reason for that?
No, there's no reason for that. It doesn't have to be there.
So it's okay even if there's no large space?
It's okay, yeah. If there were no spaces, it would be okay.
Okay. And for that line that is just below the 1SD, 2D, 3N, and then there's the asterisk there. The line before that starts with the semicolon, and then there are certain number of dashes. You've got to follow exactly the same number of dashes.
Yes, the one should line up with the first B. This basically tells you which item number, and then the A's and the B's are the direction of scoring for each item.
I see. So the idea of those numbers are related to the A's or the B's that are below it.
That's right, because that's going to tell us whether the items are scored forward or reverse.
Okay.
Is everyone done? Okay. Back together again. Okay, so let's take a look at the stuff that you typed in so that we know what it actually does. The mRange command controls how many logits will be displayed on our graphs. And even though the interval level scales are supposed to run from -infinity to +infinity, there's no way we can display -infinity to +infinity. We can only display part of that. So this will determine the number. If you multiply this by 2, it'll actually determine the number of logits that are going to be displayed on the graph. So here where it says mRange equals 2, it means that a region from -2 logits to +2 logits will be displayed on the graphs. Then this CL file equals, this gives the different levels of the Likert type variable. All right, so the 1s are strongly disagree, the 2s are disagree, 3 is neutral, 4 is agree, 5 is strongly agree. So instead of just having these numbers in the output, we will also have the labels, so we actually know what the numbers mean. And then this, as we said, we have the dashes here, 1, 2, 3, 4, 5, 6. Well, everything after a colon is a semi-comment. I'm sorry, everything after the semicolon is a comment. So we've got the dashes, we've dashed over here so that we can see what number item that we're dealing with. This I refer, the string of B's and A's, this controls whether the item is scored in a forward direction or a reverse direction. So I refer equals B, this means the item is scored 5, 4, 3, 2, 1. I refer equals A means the item is scored 1, 2, 3, 4, 5. Okay? So the reason that these numbers are up here is just to tell us what item gets what scoring direction. Question?
Raj, question.
Yeah.
This just above that is the asterisk below 5SA.
Right.
What's the asterisk for?
The asterisk is just telling you that this is where the different levels of the item begin and end. That's it. That's all it means. So WinSteps needs to know where the levels of the items are. It knows that they're inside these asterisks.
Okay.
Okay. Then below this, below the I refer statement, we need to know how to delete items from our scale. That's an essential part of what we do, right? We have to go through and find out what are the best items. So we need a way of deleting items. There are 2 ways to delete items in WinSteps. The first is with this statement, I delete equals, and then you give a list of items. So the list of items might be 3, space, 7, space, 19. That would mean that items 3, 7, and 19 will be deleted from the analysis. Now, you'll see that there's a semicolon right here in front of I delete equals 3. This means that this line is commented out, so nothing will be deleted from our analysis. Okay, even though the line is there, it's after a semicolon. WinSteps is not going to consider that. If we uncommented this line, then suddenly we could delete item 3 from our analysis. So if our statement was I delete is equal to 8 space 5 space 2, that means 8. The items 8, 5, and 2 would be deleted from the analysis. That's one way to delete items. The second way to delete items is only to select items into the analysis. So WinSteps will look at the first couple of characters here, like here's a statement, I select equals FFM. It will try to match this FFM against the first couple of characters of the item. And if it finds a match, then it will select that item into the analysis. Any item not selected into the analysis is not considered, it's deleted. So if we just wanted to consider the FFM variables, then we would uncomment this line, iSelect equals FFM. So what you've got here in this data file, you've got the 5-factor model, the NeoPI, and the Hexaco model both have anxiety scales, and both scales are 8 items. So what I've done here is I've just put the 2 scales together in the same data file, have data on the same subjects for both of those scales. That put them together here in the same data file. If you just want to look at the Neo items, then you would uncomment this line, iSelect equals FFM, and the Neo items, the 5-factor model items, would be selected into the analysis. If you just wanted to look at the Hexaco items, then you would uncomment this line, iSelect is equal to HEX, and just the Hexaco items would be selected into the analysis. If you want all the items to be in the analysis, then you can just comment out these lines, and WinSteps will automatically include everything it finds. Okay? And then finally, if you wanted to change, you can type in letters down here dynamically. So if you wanted to select a subset of items that start with the letter I, you could create a line that says iSelect equals I, and then you could put an I here, an I here, an I here, and only items that began with the letter I would be selected into the analysis. So that's another convenient way of choosing items. All right. So here is the item level data. We're continuing to edit your file now. You've already typed in your stuff. So if you look at your file, you will see that you have FFM_001 semicolon. I am not a worrier. So this was the variable name from SPSS. This was the variable label. But you'll notice this semicolon here. This means that anything after a semicolon is a comment. So WinSteps ignores this. You want to go through and delete this entire vertical line of semicolons. And that means that the item text will now appear in your analysis, not just the variable name. So go ahead and delete these semicolons here. So are we ready? Okay. All right, now save the file and exit Notepad. You definitely want to save your changes. Okay, so you saved the file and exited Notepad, right? So now go back to WinSteps, or if you stopped WinSteps, start it again. And you should see this line, control file name question mark, and it says press enter for dialog box. And so when this is how WinSteps is going to look when it started, WinSteps needs to know, what am I analyzing, right? So the first thing that it's going to ask you is to find the command file.
So we open that file. Remove the file.
So did you find your way back to WinSteps? Okay, were you guys able to start WinSteps and find your way back to this screen?
Just open the new package. Don't sign in.
Okay, so go ahead and press enter. You'll find a dialog box. Find the file that you edited. select that, and WinSteps will run. And at that point, a whole lot of output is going to go by. And what you're seeing here is that WinSteps is going through this process of calculating, estimating personability and item difficulty, then comparing item personability and item difficulty, trying to reconstruct the original matrix of responses, and minimizing the number of missed predictions. So when it optimizes its ability to predict the original data from the personabilities and item difficulties, then it's at the end and it's ready to report its results. So we'll just kind of go over that a little bit. You'll see that there is this, at the top, you'll see this output that says input data record, and it actually gives you the data for the first record, the first person. So it's got 33333, and then below that you'll see there's a caret and an I. This means that the item data began right here in the first column, which is what we told it to do, right? And then you'll see caret in, and it's pointing up here. So this is where the person names actually begin. Okay, and then caret P. Actually, I think the person data begins right here. So this tells us where the items, and the persons are. Okay? And then below this is all of this estimation process that we talked about. There's two forms of estimation. There's one called PROX and one called JMLE. And PROX is fast, but it's not as accurate. So Mike Lineker, who is the programmer of WinSteps, uses PROX to give approximate answers, and then he feeds this into the more accurate algorithm JMLE, and that's what gives the final estimates of personability and item difficulty. And then that's followed by statistics for the entire sample. Usually this is not really too important because it's, what we're really interested in is the item level data, right? So then you should be faced with a blank screen. Okay, so after WinSteps runs, you're going to have this output. You have this output that will go by, but Notepad hasn't popped up yet. And as we said, the results of WinSteps are reported in Notepad. So you'll see this thing called the diagnosis menu here on WinSteps, and this is where you're going to do most of your work. Not all of your work. This is where you'll do most of your work. The most important outputs, Mike Lineker has pulled them together and put them under this menu, the diagnosis menu. So you want to select the top one under the diagnosis menu. Go ahead and select item polarity. Okay, so you select item polarity, and at that point, Notepad should launch, and it's got output that looks something like this in it. Does that happen for everyone?
Yes.
Okay, good. Then we're all together. The first thing that you want to do is check the center column of the item polarity table. You want to verify that all of the point measure correlations are positive. These point measure correlations here, this says PT measure, this is point measure correlation. It's basically the item scale correlations. Okay, they're reported at the center of the item polarity table. Is this one negative? Is the first one negative on your guys' output?
Yes.
Okay, so what that's telling you, you remember that when we worked with SPSS and we found that the correlation, the item scale correlation was negative, we had to change the scoring direction of the item. So you've got to do the same thing here. Okay, so this is item 031, I'm easily frightened. This is entry number 5. It's the 5th item. It's scored in the wrong direction. Go back to your Notepad file and change the scoring direction for that item in the I refer statement. Okay? So the easy way to get back to the control file from WinSteps, there's an easy way to do this. You go to the File menu, and you'll notice that the first line here is Edit Control File equals, and it gives the path to the anxiety file, to the command file. So if you just select this first entry on the file, underneath the File menu, your command file will pop up in Notepad, and you'll be able to edit it.
So we will change.
Okay, so here is the line that you want to change, and you can see that the 5 lines up with the B here. And you want to change the B to an A and resave the file.
Save again. Then
Save it again.
save. Then exit. Change. Then what to do? We run again. Exit and restart. Go.
So I have to like move that.
Okay, were you guys able to do that?
And run again.
Raj question.
Yeah.
Why did the entry number become 3?
What's that?
The entry number, it used to be 5.
Yeah.
Now it's 3.
Okay, so you must have already reran it. Is that right?
Yeah.
Okay, because there are, I guess it changed because there are fewer, well, you didn't actually delete an item, so it should be the same. Yeah, I don't think it should change. Because you just changed the scoring direction of the item, right? Well, I think what has changed is the order of the items, and the 5 is probably lower on the list now. Is that right? Look at, on the in the left-hand column, it says entry number. Do you find the 5 anywhere?
The number 5 is gone lower down. Number 5 is gone lower down.
It's where?
It's rearranged itself and it's gone lower down.
Yeah, it's lower down now because the items are ordered in terms of their point measure correlation. So 3 is now at the top and 5 is lower in the list.
Oh, so when you reverse the sign.
That's right. You reverse the sign in the...
Okay.
Okay. Okay, so after you made that change to your command file, then you would exit and restart WinSteps. And WinSteps will now pick up, it basically starts over again, and it remembers the command file, and it runs with your new command file. So this is going to be the workflow in WinSteps. It's going to be find your command file, run your command file, make a change to your command file, we'll look at some output, and then on the basis of that output, you'll make a change in your command file, save your command file, and then exit and restart WinSteps. So over here on the File menu, these first 2 lines, Edit Control File and Exit and Restart WinSteps, you're going to be using those a lot because those 2 are going to help you control your workflow. Okay? So you exit and restart WinSteps, and then you find something that looks like this, and the first point measure correlation is what, 0.19? Okay. So these are basically the item scale correlations, and you're familiar with those from the work that you did with SPSS. But there's something that you need to know about them, and that is these are not corrected item scale correlations. Okay, so these are, whereas in SPSS we recognized that we needed to remove the item from the raw score scale total so that it wasn't spuriously inflated. These are not corrected. Okay, so that's important. They're probably a little higher than they need to be. All right. So let's go ahead and get the internal consistency because that's something that we're familiar with. So go back to the diagnosis menu, and you'll notice at the bottom of the diagnosis menu there's something called the separation table. And the text I have here is wrong, but just select separation table here from the diagnosis menu, and that's going to pop up in Notepad this screen. And right in the middle of this, it's going to say Cronbach's alpha test reliability equals 0.70. So there's alpha. Are you guys with me? So go to the diagnosis menu, select separation table, Notepad launches, it has this output in it, in the center of this is alpha. Are we all together? Okay. So now we actually want to make a change. We're able to get some output. We're able to get the item polarity table, and we know where alpha is. So we're actually able to get some feedback on our scale. So now we basically want to make a change. So if we look at our item polarity table here, we go back and look at that, we'll see that after we changed the scoring direction of item 5, you guys already did that, we ran it again, and we find that item 3 is only correlated with the scale 0.19. And it's not even a corrected item total correlation. This is too high. It should be lower, right? And so this is pretty miserable. So we decide that we want to delete item 3. So we're going to go back to our command file, and you guys know how to find the command file, right? It's on the file menu. It's the first entry on the file menu. And go ahead and uncomment this line that says I delete. So to uncomment it means that you will remove the semicolon in front of it and make it read I delete is equal to 3. And that's going to delete item 3. And then save your changes and rerun the file.
Raj, just
Yeah.
clarification.
Yeah.
They're just going to delete the item, right?
Yeah, they just want to delete that one item. Just I delete is equal to 3. We're just going to do one item right now.
Okay, and then we restart, right?
That's right. Save your changes and restart. You have to save your changes, otherwise WinSteps won't pick it up. So remember, on the file menu are the two very often used menu items, edit control file and exit and restart. And that's always going to be your workflow in WinSteps. Start WinSteps, find your command file, WinSteps will run, you'll take a look at some output, you'll edit your command file, you'll save your changes, you'll exit and restart WinSteps, you'll look at some more output, you'll make some more changes, you'll exit and restart WinSteps, you'll look at some more output, make some more changes. That's your workflow. So you guys ready?
There.
Okay. So at this point, just go ahead and pat yourself on the back because, yay. So basically what we did here, we had data on the same scale. We had data that was supposed to be data relevant to the same construct, anxiety, but it's the same construct in two different inventories. It's in the Hexaco inventory and the NEO PIR. These are supposed to be, particularly the NEO is a professional, that's a professional inventory, right? You can go out, you have to pay money for the NEO, okay? And it's supposed to be well constructed and so on and so forth. The Hexaco is a competing factor model. It's a 6-factor model instead of a 5-factor model. The two things are very similar. The Hexaco has been translated into a lot of languages. It's also a respectable inventory. What you did was you took items that were supposed to measure the same construct, you put them together in the same WinSteps file, and you analyzed the items and basically constructed a single scale. You put the items into the same frame of reference. You took what were two separate scales and you combined them into one thing. Okay, and that's the data. That's the data that you essentially have in front of you right there. And that's just how easy it is. It's really pretty easy. When you get used to the workflow, it's not hard at all to do that. And you'll get used to that over time. So that's, again, that's just the workflow in WinSteps. Review some output, edit the command file, save the command file, exit and restart WinSteps, and then repeat. Okay? So let's take a look at the item polarity table in some detail. And so over here on the left, we want to go through, we want to describe every column in the item polarity table so that you know what you're looking at. And if you thought that you got a lot of output, if you thought that you had a lot to consider when you were doing item selections in SPSS, this is a whole nother level. You get an unbelievable amount of information about every item from WinSteps. And it's at first, it's overwhelming. So you'll spend the rest of the class basically learning what this output means and being able to deal with it and do your item selection.
No sound. No sound.
No sound.
No sound.
There.
Okay. Okay. So we're back?
Yes.
Okay, great. So as I was saying, okay, so we want to take a look at the item polarity table, and we want to know what each column means on the item polarity table. And if you think that you are getting a lot of information from SPSS, you're getting an overwhelming amount of information from WinSteps. And you have to learn where the information is at, and you have to learn what it means, and it will take the rest of the semester to basically get used to it and be able to manage it. So let's take a look at each column in the item polarity table and explain what the meaning is. So over here on the left, you have this entry number, and this is basically the item. This is the number of the item. So if it says a 10 here, this is the 10th entry in terms of the items, okay? Then the next column is called total score. So this is, if you take all of the subjects and add up all their Likert levels, this is the result. This is called the total score. The total count is the number of subjects that answered the item. Okay, that's all pretty easy to understand, right? And then the next column is called measure. What in the world is this? Okay, so remember we had the matrix of ones and zeros, and we explained how that qualitative data could be transformed into an interval level of measurement called logits. This is the difficulty level of each item in logits. Okay, the items are arranged in terms of their correlation, but this is the difficulty level of each of the items in logits. Now, by convention, a zero means this is the mean of the item difficulties. All right. So if you have a measure here of 0.46, it means that this item is 0.46 logits harder than the mean of the item difficulties. And that's not the same thing as the mean of the person abilities. It's the mean of the item difficulties. So this is the hardness of the item, the easiest or hardness, the difficulty level of the item compared to all other items. Not compared to the persons, but compared to all other items. So this item, this 0.46, this item is a little harder than the other items. Then the next one is 0.97. And if you look down at the entire list, you'll see that this is the most difficult item on the list. Okay? And then these negative numbers, the minus 0.68, well, this is an easier item. Okay? The minus 0.88, this is the easiest item. All right? Okay. And now, if you look at this, this is the person item map that we talked about earlier. So we talked about this in terms of targeting. So if we look at that, this is the, you see this letter M here? This is the mean of the item difficulties. And basically what this is intended to prove to you is that this is the 0 here in terms of the reported measure. In this measure column earlier, this is where the difficulty levels of the items are being reported. The 0 is right here. So you can see that most of the persons are actually below this. So you can't look at the item difficulties and think, well, this is where most people are scoring. It's not the case. All right? If you want to know about targeting, you actually have to look at this output. All right? And then this column, Model SE, these measure estimates, these are just estimates derived from the sample. Each one has a standard error of measurement that's associated with it. This is the standard error of measurement for this particular estimate. So usually this is not very important. These are going to hopefully be low numbers. Then the next column is called infit. And you remember that there was this transition zone here in which person ability and item difficulty are approximately equal. Well, these two columns tell us if we observe the expected pattern. Remember, the expected pattern here is that we expect to find failures on the left and successes on the right. Okay, there's a lot of chaos inside this initial transition zone, but we expect to observe failures on the left and passes on the right. So we expect to have zeros here and ones here, not the reverse where we have successes on the left and failures on the right. So this would be the expected pattern. If this is the pattern, then this is going to generate some infit because this is unexpected. Okay. Values greater than 1.4 or less than 0.7 are going to be suspicious. And when I say that, I'm referring to the values here. All right. This column gives us what's called the z-value of each one of the infits. The problem with these z-values is that they are influenced by sample size. So if you have a very large sample, these values are going to be huge. They're not on the same index. These mean squares column puts all of the fit statistics on the same metric, so you can actually compare them regardless of what it says over here. You're looking mainly at this column, and you're looking for values that are greater than 1.4 or less than 1.7. So values greater than 1.4 are going to indicate that the observed pattern of responses violates our expectation. There's too much noise in the data, or we're getting passes where we would expect failures and failures where we would expect passes. This is an item that's going to be a candidate to be deleted. Okay, and then if the value is less than 0.7, that actually indicates that the item may be too predictable. Okay, because the item is supposed to observe that smooth logistic function, and then this is an item that could be a candidate to be deleted. So that's what you're going to be looking at. Okay. Then the next column is outfit, and it's basically the same idea. Again, you're looking for values that are greater than 1.4 or less than 0.7. All right. Outfit, you remember the scalegram we talked about earlier. We got the transition zone in the middle. The transition zone in the middle, if it obeys our pattern of expectations, we expect to find reasonable infit. Infit is always concerned with this transition zone. It's also called an information-weighted index of fit. Outfit is concerned with what happens on either side of this transition zone. Over here, we expect the subjects to basically pass the items. If subjects fail an item over here, this is going to contribute to infit. All right? So these are items that are really too easy for the subjects. The subjects have more ability than the items have difficulty. We expect the subjects to pass the items. If the subjects fail the items instead, that's going to generate outfit. Over here, the items have more difficulty than the subjects have ability. There's a substantial difference between item difficulty and person ability, so we expect the subjects to fail the items. If the subjects pass the items instead of fail the items, that's unexpected. That's going to generate outfit. So that's what infit and outfit quantify. And again, you're going to be looking at this column that reports the mean squares, because that puts all of the fit statistics on the same metric, not influenced by sample size. If you want to see the statistic as influenced by sample size, then you'll look at the ZSTD column. Okay? So outfit is sensitive to gross violation of expectations. All right? Now, different types of tests are going to require us to adjust our expectations about what infit and outfit should be. So this column was actually constructed by Mike Lineker based upon his experience in using the Roche model. And he says that for a high-stakes multiple choice test, the kind of test that you might take in order to be licensed, for example, values that are too low or below 0.8, values that are too high are 1.2 or above. If you have a run-of-the-mill multiple choice survey, then you're looking at values between 0.7 and 1.3. Rating scale, Mike Lineker says 0.6 to 1.4. Clinical observations, 0.5 to 1.7. Apparently there's going to be a lot of noise in those observations, so you're going to have to tolerate more noise. Okay? So let's take a look at the next column, and it's called the point measure column, which I already told you guys a little bit about earlier. So since this is not the corrected item total correlation, these numbers are probably about 0.102 high. If you were to subtract 0.1 from these numbers, you would get something similar, not exact, but similar to what you would see in SPSS for the corrected item total correlation. Okay? And then this is a point, this is something that you have to consider very carefully, because usually when we do item selection, we're mainly looking at these item total correlations. And you're probably wondering, well, you know, WinSteps is so detailed in terms of the output that it gives. Why aren't these the corrected item total correlations? The reason for that is that there's a different philosophy of item selection that's at work here. And this is what Mike Lineker says. This is an exact quote from Mike Lineker about item selection in WinSteps. And Mike says that in Roche analysis, we are chiefly concerned about the predictability of the data when assessing item quality. So we examine the predictability directly using the mean square statistics rather than indirectly using correlations. What does that mean? Okay? So what that's basically saying is, remember that we have this item hierarchy, and we have the item hierarchy because we believe that our items span this vast range of difficulty, and we're trying to construct scales that range in difficulty from, in theory, minus infinity to positive infinity. So the ruler could expand an enormous distance. All right, we could have items that assess every point on that scale over an enormous distance, and that means that we could have items that are so difficult that they don't really get too much of an endorsement. If you've constructed your item hierarchy based on theory, okay, let's go back to remember the religiosity slide that I had earlier. if you constructed your items based on theory, you could have items that are so difficult that very few people in a normal population will endorse them. And those items are going to have, because they get very few endorsements, those items are going to have a very low correlation with the rest of the scale. If you're using a classical psychometric framework and you're talking about alpha, those items have a very low item total correlation. Those items are actually going to subtract from alpha, and they're going to get kicked out of the analysis just because they don't get endorsed very much. So if you have people that fall into the 99th percentile of religiosity, and you have items that are matched to their level of ability, their amount of the trait, those items aren't going to be endorsed very much if you're just using college students to construct your scale. So those items are going to have a very low item scale correlation. They subtract from alpha. They actually get kicked out of the analysis. Items that have a high level of difficulty tend to have a low item scale correlation, and they're kicked out in classical psychometrics because their item scale correlation is low. So we need a way of determining whether those items are actually on the construct. And so instead of emphasizing the item scale correlation, we don't require the item scale correlation to be, say, 0.4 or 0.5 or 0.6, the way that we did when you were working with SPSS. Instead, we only require that the item scale correlation be moderate and that the infit and outfit be within the normal range. Okay? So whenever you work with WinSteps, particularly if you're working with ability data, personality data is a little bit different, but particularly if you're working with ability data, if you see a moderate correlation, a moderately sized correlation over here, and you see infit and outfit are normal, infit and outfit are constructed so that their optimal value is 1.0. So if you see this 0.99 and 1.02, these values are good. These are good fit values, okay? And the correlation is, low, but it's still all right. This item could be okay, particularly if it's an ability item. And if you look over here at its measure is 0.97, so the item is fairly difficult compared to other items. So this item could be okay. This item here that has a 0.22 correlation, well, it doesn't fit the data too well. It's beyond our 1.4 that we were talking about earlier. Its fit statistics are marginal, and it's 0.46, so it's more difficult than the average item, but it's not that difficult. This item is probably a bad item. This item should probably be thrown out. So the logic of item selection is a little bit difficult because the philosophy that is associated with our measurement framework is different. Okay. All right, so we're going to look at item 11, and we're going to see that its fit statistics are okay. We're going to see that its item scale correlation is moderate. Let's take a look at actually the skew of the item. Go to your item polarity table, go to the diagnosis menu, and then go to item polarity, and pull up the output for that. And then go ahead and scroll down. And when you scroll down, you're going to find that you can see each level of the item, and here you'll see the raw number, the frequency of subjects that fall into each level of the Likert type item. And then this is the percentage of people in each level of the Likert type item. So in terms of item 11, we've only got 12% of the subjects that agree or strongly disagree. That means the item is highly skewed. And because the item is highly skewed, well, that attenuates the correlation that it can achieve with the scale. So from a certain measurement perspective, particularly if we were working with ability level data, this item could potentially be considered to be okay. All right? So if we go to and you're going to see this even more if we go to the item person map, go to output tables, go to the output tables menu in WinSteps, and select 12 item map. think Mike has all of the tables that WinSteps can output numbered. So you want to go to the Output Tables menu and select 12 Item Map. And that's going to pop up this table here. And you're going to notice that the difficulty level of this item, this is the most difficult item. It's way up here at the top of the distribution. So we found a reason why the item scale correlation here, we found the reasons to account for this attenuated item scale correlation. So if you put all of that together, that could argue that the item conforms to the construct just because it's a very difficult item, especially relative to the person mean. So is this item on construct? Well, it's kind of a judgment call, and it depends upon whether you want to work in a traditional personality framework or whether you want to work in a Roche framework. Okay? So let's look at the next column. Go back to the item polarity table. We look at the next column of data, and you'll see there's a column here called exact match, exact observed, and then the next column is called match expected. The exact observed is this is the extent to which the Roche model was able to correctly predict the item responses. And then this is the level of match that would have been expected if the model fit the data perfectly. So we expect these two numbers to be, in general, we expect these two numbers to be pretty close. Okay? If you look at these numbers, you're going to see some deviation. The model, obviously the data never fit the model perfectly, but nevertheless, if it's a good item particularly, they should be pretty close. Here's an example where the model underfits the data. So we observe that about 45% of the subjects are correctly predicted, but we would expect about 50% to fit the data if the model held perfectly. In that situation, that means that there's more noise in the data that we expected, and that's going to tend to generate high levels of infit and outfit. We can have this other situation in which we actually are able to predict the data more than expected, and that's called overfit, and that's going to tend to lead to infit and outfit that are less than 1.0. That's not, I don't think that that's inevitably true, but that tends to be true. Okay? Now let's take a look at something called the empirical items category table. And I just want you to basically look at the outputs that I have. We're not going to run WinSteps on this yet, so just look at the screens that I have. So I took the BIA data. Let me tell you where the data comes from. I took the BIA data from the IPIP, and you remember that I had went through all of the data and I had selected items that I thought might be on construct, and then you guys analyzed those in SPSS. So this is basically looking at all of the curiosity items. And when I do the item scale correlations here, I notice that I've got an item that's scored in the wrong direction. So I basically correct that. Well, I got an item that's scored in the wrong direction, and you see that its correlation with the scale is minus 0.34. So we want to look at the empirical items category table. If you go to the diagnosis menu and drop that down, you'll notice that there is a selection there for empirical item categories. And what you're observing here, here's the score in logits along the bottom. So this varies from -3 to +3. This was controlled by the mrange command that we typed into the command file earlier. And this is where all of the levels of these Likert type items fall in terms of the difficulty. So here is the item text, and here where all of the levels of our Likert type items are. The ideal item, in the ideal item, the levels ascend in an orderly manner. So they always go 1, 2, 3, 4, 5, or if the item is reverse scored, they go 5, 4, 3, 2, 1. Okay? For this item, which is inversely correlated with the scale because it's scored in the wrong direction, we know that this item, we've got to do something with this item because it's scored in the wrong direction. So first of all, let's just take a look just to see how it looks. let's take a look at its levels. And we can see that when the item is scored in the wrong direction, the levels go 3, 4, 2, 1, 5. So the levels of the item are all mixed up because the item is scored in the wrong direction. The item looks bizarre here in terms of our empirical item categories. So we've got to basically correct that. We would go through and we would edit the item and we would correct that. Let's see, that was entry number 81. So when we correct this and we tell WinSteps to calculate the table again, previously this was the most difficult item. The items here are in order from most difficult to the top and easiest at the bottom. So when we correct that, now the item difficulty drops. The item is reported down here, but you'll notice that the levels of the item are still disordered. So even though we corrected the item, well, it didn't really do a whole lot for the item. So this item is probably not really a great item. So as we said, the item text here, the most difficult items are at the top, the easiest items are at the bottom. And then you'll notice that there's this thing down here at the bottom of this output. And this is the 0 here is the mean of the item difficulties. And then there's this little graph here, numbers here. And this is kind of a frequency table. And so you can kind of look at this and you can get an idea of what the targeting is. So you've got the M here, which is the mean of the person abilities. So this is the mean of the item difficulties. This is the mean of the person abilities. You can see that the persons have a lot more ability than the items have difficulty, and that's why most of the levels of the item are up here. Okay, most of the levels of the Likert type items fall above 0. So you can get an idea of targeting by looking at that. Okay, so we go back to this item, curiosity. This item was disordered. Okay, 3, 2, 1, 4, 5 in terms of the levels. If we go back to the item polarity table and we look at the frequencies of the items, we see that this column reports the measure of each level in logits, and we can see that they don't ascend in a uniform manner. That's why they have little asterisks by them. The item is highly skewed. So since the item is highly skewed, and since 92% of the subjects basically report agree or strongly agree, that leaves very little data which is in these other levels of the item. So because there's very little data in these other levels of the item, it's difficult to estimate the difficulty levels that are associated, the difficulty values that are associated with the levels of the item. So there's not a whole lot of data here. And that's one of the reasons why the levels appear to be disordered. So this item is so skewed that agree and strongly agree tend to pull all the data to themselves. The rest of the levels of the item don't get a lot of data. It's difficult to estimate their ability levels. Bad item should probably be deleted. Now, Mike Lineker says that you need at least 10 subjects in each level of a Likert type item in order to get a good estimate of its difficulty. My experience is that 10 is sometimes good, but sometimes more are needed. So instead of 10, I would say maybe 10 or 20, 15 or 20 sometimes you need. If you have too few levels, you're just going to tend to have disordered categories, and that's not going to be good, and such items are probably going to end up needing to be thrown out. Okay? Let's see what else I have here. Okay, so you see that at the bottom of the empirical item categories, you've got the T, the S, the M. So the S is 1 standard deviation away from the mean of the person abilities, and the T is 2 standard deviations away from the mean of the person abilities. All right? And then we can see the same thing. We get convergent information. We can see the same information displayed in another way on the person item map. So on the person item map, this is the mean of the person abilities, and this is the mean of the item difficulties. All right? And then we want to take a look at how do we find dependent items. And I guess what we'll do is we'll go ahead and take a break, and we'll consider that next time since we're running out of time. Any questions on any of this? Okay, so it's about what, 10 till 9 there?
Yeah.
Okay, so we got up to slide 112 of 134. I want you guys to go ahead and look at the rest of the slides and see if you can complete the assignment based on the rest of the slides for next time. Okay? Questions? No questions. Okay, well, if there are no questions, I guess we'll call it quits, and we'll go ahead and meet up next time. Okay, bye-bye. Bye-bye.
Bye. Thanks.
Bye-bye, Val.
Bye.
What's the